All right, sorry about that. Here we go. Topic 7-8, more differential equations, but this time we're going to be talking about exponential models. Some of you may have heard of Newton's law of cooling. You do not need to know Newton's law of cooling for the AP exam. They won't refer to it. They may use it, but they're not going to refer to it as Newton's law of cooling. But you will have some story problems, growth and decay type problems, that type of thing. So let's take a look at what it might look like. First of all, if they talk about the rate of change of y, the rate of change of y is proportional to y. So if you remember from back in, probably 9th or 10th grade, direct proportion, inverse proportion, these are directly proportional to each other. So if you see proportional, it'll be a k. So proportional to y is k times y. Okay, so you have exponential growth and decay model theorem. This theorem right here, c times e to the kt. This is the equation that you want to just memorize to make all of these easier, okay? So instead of having to take a derivative and solve, just know that the antiderivative, the integral, that the antiderivative or the integral will give you this, okay? If you memorize that and not have to work it out, it'll save you a lot of time, okay? So C is your initial value, okay? K is the proportionality constant. And exponential growth is when your K is positive and decay is when your K is negative. So just memorize this, and these problems are a piece of cake. And there's not a ton of them, so let's just take a look. It says the rate of change of y is proportional to y. So that's what you want to look for. The rate of change of y is proportional to y. So anytime you see that, you want to use the antiderivative. Okay, this right here is antiderivative is equivalent to this. So we can just memorize that. I'll prove it to you later if you really want to. Okay. All right, so we're going to use this. So the first thing you do is you plug in the first point that's given. Okay, so the first point that's given to us is 0, 2. So we're going to go ahead and plug that in. So 2 equals C times E K times our T value of 0. So E to the 0 is 1. So that means that C is equal to 2. Okay, so that's the first thing that you're going to do. The next thing you're going to do is you're going to plug in your second point, which is what? 0, 4, right? So that gives us 4 is equal to 2 times E to the K. Oops, not 0, sorry, T is equal to 2. So it gives us this. And that's basically telling us that E to the 2K is 4 divided by 2. Okay? We're trying to find K. We're trying to find K. Oh, and if you didn't realize, I'm sorry, I skipped right over this. This 2 right here is this 2 right here. Okay? So the first thing we did, step 1, is plug in the first point. And we found C. The second step is to plug in C with the second point that's given. So that's what we've done so far. Okay? So that C goes here, the second point that goes with it, T, and y. We're trying to find k. How do you solve this? Well, this is an exponential equation. Exponential equations you can change to log form, or you can take the natural log of both sides. So I believe that when we learned it, we took to solve an exponential equation, we changed it to log form. Okay, so we're just going to go with that. The natural log, a log is equal to the exponent, right? Log is equal to the exponent. E is your base. Well, isn't that redundant right there? So we really don't need to write that. So isn't that exponential form to logarithmic form? Let's check. E to the 2k equals 2. Remember circle method? E to the 2k equals 2. Exponential form, logarithmic form. Okay, but again, we don't need that because that's redundant. So basically it's telling us that k is equal to 1/2 the natural log of 2. So if we go back up to our original equation, our solution would be y equals our c value, which you calculated to be a 2, times e to the kt. And our k is 1/2 the natural log of 2, all of that, times t. Now, this has an added step. This is the solution. And again, you could put that 1/2 up here, and it could be the ln of the square root of 2. However you want it, whatever log properties you want. Again, if it's multiple choice, they might put that 1/2 up here and call that the square root of 2. That's your exponent properties for logarithms. But in this particular one, it says, what is the value of y when t equals 3? So when you see what is the value of y when t equals 3, you have to know, and this is going back to the last couple sections as well. When they ask you a question like this, that goes back to that you have to know that you're finding the particular solution. In the last couple of topics, they said find the particular solution. This one says find the y value, which means you need the particular solution. So this is the particular solution. So then our last step is going to be to actually find the value of y when t is equal to 3. So y is equal to 2 times e to the 1/2 times the ln of 2, right? And all of that is going to be multiplied by 3. And again, these are usually non-calculator problems. If this is a free response question, you can leave it. Anything that can be typed into a scientific calculator, you can leave. This is an acceptable answer on a free response. However, on a multiple choice, it's not going to look like that. We have to do some simplifying here. So we could simplify it to 2 times e. This 3 gets multiplied by the 1/2. Okay. That can get turned into e to the ln of 2 to the 3/2. And let's see if you remember what all of this is equal to. All of that is equal to just all of this here. These bases are the same. This is base e, this is base e. It's just equal to 2 to the 3/2. So that's 2 to the 2/2. That's 2 to the first, times 2 to the 3/2, which equals 2 to the what? To the 5/2. Now, different ways you can take the square root of 2. We don't know the square root of 2. We could do 2 to the 5th. So it's the square root, I don't need that 2, I guess, of 32, which reduces to 4 square roots of 2. And 4 square roots of 2 could be a multiple choice answer. Okay. 4 times the square root of 2 is approximately 5.657. So graphically, this is what our example looks like that we're doing right now. Let's go over to, let's just kind of check our answer. They're not going to give you the graph, but I gave it to you just so you can see that our answer is correct. When you go over to t equals 3, you go up here, you're a little bit more than 5, a little bit less than 6, so 5.657. Again, this will not, it could be a calculator problem on the multiple choice. But again, on a free response, stop here. Always stop if you can type it into a scientific calculator. If you really want to go back and simplify later on, if you have time, then do that. Okay. We have a couple other applications for growth and decay. I'm sure you all have heard of half-life. So let's take a look at this particular example. You're starting with 15 grams. How long will it take for 15 grams? Again, how long will it take? It's asking you to solve something in this problem, which means we need to find the particular solution. Okay, we need to find the particular solution. So let's go ahead and let's see what they give us. You start with 15 grams, right? So that is 0, 15. And we're talking about, what is that? Caesium? I'm sure you guys know more than I do. That's right here. Here is its half-life, 30 years. 30 years. So 30 years later, how much would you have? 7.5. Right? Half of what you started with. Okay. So again, we're going to use our equation, y equals c times e to the kt, because again, we're talking about exponential growth and exponential decay. So just memorize this, and it'll save you a lot of time. All right, so we're going to start with our first point. Y is 15 when this is k times 0. So basically, anytime that's 0, that's your C. That's your initial amount. So you really don't even need to do that work. 0 means initial amount. C is initial condition. So our equation is y equals 15 times e to the kt. Okay, so we're going to then use our second point, which is 7.5 after 30 years, so that's 30k. Divide both sides by 15. Well, it's half-life, so you're going to get a half. Okay, so again, I showed you how to change it from exponential form to log form. Again, another way is just taking the natural log of both sides. That is also another method for solving an exponential equation. You take your pick. So the natural log of 1/2, the natural log of e to the 30k is 30k. So k is 1/30 times the natural log of 1/2. So our equation, our solution, our particular solution is y equals 15e to the 1/30 times the natural log of 1/2, that's our k, times t. Okay, so then when we go, how long will it take for the 15 grams that we started with to decay to 1 gram? How long will it take? They're asking us to solve for t. So I'm going to take this equation, I'm going to write it up here. So they must be giving us y. They want us to have 1 gram. 15 times E. I'm going to go ahead and change that to the natural log of 1/2 see this down here? This is, I'm going to move this T here. If you don't mind, I can move that T there because it makes it a lot easier if I do that. And now I can have 1/2, the natural log of 1/2, all of that. That T to the 30th, that's the exponent properties for logarithms. It's in the front. I can move it to the exponent. Okay, actually the exponent of one-half. Sorry guys, long day. There. Okay, so this coefficient can go up to the exponent of the 1/2. Exponent properties of logarithms. Okay, so how does that help me? Well, again, we have a formula, and again, I'll go ahead and write it down for those of you who don't remember, that if you have b log of base b of x, that's just equal to x. So this is base e, this is base e, so the bases are the same, so it's just equal to this. So that's one of the log properties way back when. So if we continue with this, we get 1 equals 15, and all of this is equivalent to what? 1/2 times t divided by 30. Now, bad math, multiplying these two together, that's bad math. So I have to divide by 15. And I have an exponential equation, which I can turn to log form or simply just take the log of both sides. That's just my preference. Again, completely up to you. And because you take the log of both sides, you can now move that in the front. So for those of you who hated your logarithms unit in 10th grade, you probably won't like this section. So that gives me the natural log of 1/15 equals t over 30 times the natural log of 1/2. Again, I'm trying to solve for t. What would you do first? I don't know, I guess it's completely up to you. I'm going to go ahead and I'm going to take the natural log of 1/15 and I'm going to divide it by the natural log of 1/2. And then I'll multiply both sides by 30. And again, this is going to be a calculator problem. So t is approximately equal to, you can go ahead and check it on your calculator. I would practice typing this in very carefully because you have your fractions. You don't want to mess up your parentheses. T is going to be approximately 117.207 years. Okay, so this is usually a multiple choice question. That's a lot of work for 1.2 points. You know, something you might want to do last. Okay. All right, I'm going to stop this video right here.